So this lesson will be our introduction to nuclear chemistry. So when you think of nuclear chemistry, you can think of nuclear energy or even the nuclear bomb. So this is going to be talking about the basis of nuclear chemistry. So remember that all atoms are composed of three different things. They are, let me pull this over here. Atoms are made of protons, neutrons, and electrons. So remember that protons and neutrons are found in the nucleus or center of the atom. So if you look at this little picture right here, the protons and the neutrons, the plus ones are protons and the green ones with no charge are neutrons. They're in the middle in the nucleus of the atom, and the electrons are the ones that are around the atom. So to keep it simple, protons and neutrons are in the nucleus of the atom, while electrons are found around the nucleus. So for most of chemistry, we've been focusing on the changes in the electrons. So remember how these things either they get shared or they get transferred, or metallic bonds that get delocalized. But you got to remember that there are these two other particles, protons and neutrons, and we're going to focus on reactions that are focusing on changing the nuclear structure. And that was actually first discovered back in 1896 with the discovery of radioactivity. The goal of this first lesson is to introduce you to nuclear notation. So before we do that, we need to review some facts from earlier in chemistry. So remember that the number of protons is what defines an atom. So every single atom has a different number of protons. So hydrogen has 1, helium has 2, lithium has 3. The atomic number on the periodic table is actually what determines that. So let me write it down. Remember, for protons, is equal to the atomic number. So if you have a periodic table, which you can just look up online, there's so many of them, atomic number, you can pull it up, just like I'm going to pull one up right here that I got from ptable.com. And you can look at the atomic number. So for hydrogen it's 1, helium 2, carbon has 6. So all of these numbers represent the number of protons. So this really is very important and crucial in defining the atom, the number of protons. Whereas the number of neutrons is actually something you can find from the atomic mass. So let me actually just write that, but it's not exactly the atomic mass. So neutrons, the way you can do it is actually going to be the atomic mass, which the atomic mass is the protons and neutrons. So you get just the neutrons, it's just going to be the atomic mass, and then we're going to do a minus the atomic number. And that's going to give you the neutrons. So I'm going to put neutrons down here. Remember, that's a minus. So, for example, if you had, let's look at lithium right here. Lithium has a mass number of 6.94. That's this bottom number right here. The easier way to do it is usually you're going to have to round to the nearest number. And sometimes they'll give you different isotopes because different atoms can have different number of neutrons. Number of neutrons does not matter in defining the atom. It's what the protons are. So in this case, most lithium has about 7. That's why it's close to 7. So we're going to round that to 7. Which would be 7 minus 3. So let's do it right here. So we know that. Let me pull this down. So the way we'll write that, lithium, and we'll put a little dash, 7, that's a mass. So this is the mass number right here. So if you're trying to find just the neutrons, we know for sure it's got 3 protons, right? And for neutrons, what you do is take that 7 minus the 3 protons is equal to 4 neutrons. If you had something like, let's say, lithium 6, which is another isotope, which just means it has a different number of neutrons than normal, or than the most prevalent, then you'll have lithium 6. And remember, it always has 3 protons, right? And you have instead of 7, it's going to be 6 minus 3. is equal to 3, and that's going to be 3 neutrons. So 3 protons and 3 neutrons. So the main goal of recapping this is to get into nuclear notation. So nuclear notation is actually just a way to write atoms. And actually I'll write it right here. Whoops. I guess it's not giving me enough room. Alright. So it's just a way to write atoms. It just has the symbol and the atomic and mass number next to it on the left. So let's say we have, let's take lithium. We were just doing lithium. So the way you do it is you put the atomic number on the bottom left. So that's the number of protons. So remember, lithium always has 3. And you put the mass number on the top left. So let's say we're doing the lithium 7, which is the standard one if you round. So we'll just make it 7. So that is the nuclear notation for lithium. So let me actually write a basic. I'm going to put a symbol is A. That's just the element, right? And then you have the mass. I'll put mass number right there, and then atomic number right there. So I know that doesn't look that pretty, but let me show you some other examples. Let's take this out right here. Let's say we have gallium. Right here we'll have the standard gallium, which is 69.723, so let's say that's 70 for the mass and 31 for the atomic number. So it would be Ga. So that would be Ga. And remember, it's 70 for the mass and then 31 for the atomic number. So easy way to find neutrons is just you do 70 minus 31. So you know you have 31 protons, and 70 minus 31 would be 39. And so let me just do a couple more examples. Let's say we have sulfur. Sulfur is generally like 32. Got atomic number of 16. So the way we write sulfur is got a mass of 32 and a atomic number of 16. That's how you write sulfur. Let's say one last example we'll do strontium, where we have 87.62. You can round that to 88. There's also a lot of strontium that is 87. And actually for this one, I'll write the one that's 87. So let me make that clear. And then it's got 38 right there. So the way to make it clear for this is you take this and we'll do strontium. You could just call it strontium. Almost forgot how to spell that. Strontium 87 is going to be, it's just going to be the SR. And then you have a mass number of 87, because remember this is the mass, not the atomic number. And it's got the atomic number. Let's make sure I don't mix this up. It's 38, so it's a 38 right down here. And that's it for nuclear notation.